as the first thing we did was we talked about it's a unit for counting. Okay, we talked about that. Okay, and how do you convert into a unit? Okay, if you every atom, molecule, electrons, okay, you need a big unit for counting, okay, because you've got lots of atoms. So it's the number of particles divided by the Avogadro's constant, okay, and so that's the first thing. Okay, divided by the Avogadro's constant, which was 6.02 times 10 power 23. And I think we did discuss about significant figures, which I think we did not finish. Tika, I told you this was the last discussion. Is you correct? This was the last discussion we were having about significant figures, right?
Yes.
So I told you, okay, every instrument has a particular accuracy, and that accuracy is represented by the significant figures. Okay, so they represent accuracy of those values. So, for example, if you're doing if you're trying to calculate area, okay, and you're using length into breadth, so uske andar maybe the value is accurate up to 3 significant figures for length, and the value for the width would be accurate up to let's say just 1 significant figure. So your answer, if you do this calculation, 1.9 into 2, you're probably going to get 3.8, I think. It's what do you get for this? 3.8. Now the question is,
yes, sir.
So now the question is, would you write 3.80 or would you write 3.8?
3.8.
Okay, so the rule was, okay, you're going to use because one of the value is less accurate because you don't know what comes at this position. Okay, that's a question mark. The third significant figure becomes a question mark because you're not sure what that is. Is it 1.90? Is it 1.91? Is it 1.12? I mean, you have no idea what follows after that. So the third significant figure becomes doubtful, which is why your answer cannot be more accurate than the least than the number that is the least significant. It follows the least significant figure accuracy. So the answer, this is something that we did. The answer would be accurate up to the least significant figure value. And you have to be, you've got to be careful about this. Okay, so you have to be careful about this when you're solving questions. A lot of times you get lots of decimal places. It's not always 3 significant figures, but sometimes you have to write values up to 2 significant figures. Just follow this rule. It's a simple rule. Now, the other formula that we were doing, I think, was, and I also stressed, okay, remember, you have to be very quick. You have to be very quick. So if you're using ratios, whatever you're using, you just have to be, everything should be on your fingertips. Like if the question is asking for number of particles, don't think of the formula, don't think of ratios, just simply, I mean, you should be able to just figure out that moles need to be multiplied by the Avogadro. It should be, you should do it very, very quickly. The next formula was moles is equal to mass divided by the AR or MR.
Molar mass.
Okay, so that is the molar mass. So most of you know what that is. You can also use ratios in this. That's your second formula. You can use ratios, but again, you have to be very quick. Like if somebody is asking you for the mass, fingertips, I mean, you don't even have to write the formula. Just, I mean, it should be good enough to just multiply moles with DMR. That's it. I mean, it should be on your fingertips. Okay? If somebody is asking for moles, just write mass by AR on your calculator. in as little time as possible. Now about this formula, I'll just give you a brief overview of this formula. Okay, how do you do counting? TK, maybe I think I did explain this in class or not. I said counting large numbers. TK, counting large numbers is difficult. Counting small things is easy, but when you have lots of things, it becomes kind of difficult. TK, so the example is that there's this small box and it's got a bunch of apples, right? So what do? You count it one by one, like 1, 2, 3, TK. But what if there's this huge truck and that's full of apples? So what do? You can't really count it one by one because that's going to take a very long time now. TK, for example, if there are 20,000 apples in this, it would be kind of very difficult for you to count it by picking one apple at a time. The other method is this one. And that's how you count atoms as well, because atoms are also in very large quantity. What you do is you take the total mass of the apples. Let's say there are 20,000 apples and each one weighing 200 grams. So kitna ban jayega? 20 into 200, that's what do you get? Well, let me
4,000.
मैंने कितना कहा था? 20,000 apples कहा था ना. So I had 20,000 apples and each one weighing 200 grams, right? So I get 4,000, I think 4 million. The total mass. So what I do is I can calculate the total mass of the apples, okay? And what I can do is I can divide it by the mass of one apple, which is 200 grams. So I'll get it. I'll figure out, okay, it's going to be 20,000 apples in this truck. Okay, now this 200 gram is just going to be an average mass. It's going to be an approximate estimate. You can't be very accurate with this, right down to the smallest apple. You can't really be accurate, but that will give you a pretty good enough estimate. As long as your average mass of an atom kind of is reasonable enough, you'll get a pretty good estimate. Okay, is this part clear?
Yes, sir.
Yes. Yes.
So atoms ko bhi na, you count it in the same way. You can't really count them one by one. What you do is you take the total mass, and of like if you have a piece of iron, you take the mass of that iron, and then you figure out what's the mass of 1 mole of an iron atom, and you divide it by that, and you'll figure out how many moles you've got. So AR, you divide by the AR or MR, which is the molar mass, which is basically, in simple terms, that's the mass of 1 mole of atoms or molecules which is given in the periodic table. That's your AR or MR expressed in grams. So that's your AR or MR expressed in grams. Is this formula clear? This one?
Yes, sir.
Okay, you already know this.
Yes.
So now a few things that you probably don't know about this formula and about especially this AR and MR. I'm going to talk about that in detail. And again, it's something to do with significant figures, right? So you have a data booklet, which in your case, it would be, I mean, you'll still be using the data booklet. Let me just open a, you'll still be using a data booklet, except now it's not going to be a separate, it would be embedded within your exam. Isse pehle na, it was given separately. So this data booklet, which you can see on your screen, that has a lot of values. For moles, the most important page is the periodic table. That's the one that we'll deal with when we study moles, when we do a moles question. So right at the end, here's your periodic table. Okay. Now in your periodic table, every atom has two values. One is the smaller value, the other one is a bigger value. Now, one thing that you will notice is the smaller value is your atomic number or the number of protons, and then you have the bigger value, which is in decimals. So, I mean, that's the format that you're following. So I'll just copy one of them. For example, let's look at calcium over here. Okay, but let's look at magnesium over here. Achha, first thing is, don't use your memory like you're used to finding moles, right? It's not that difficult. But if somebody tells you to find the moles of magnesium, you'll take the mass and divide by 24. I mean, that's your habit. It's like sodium is you believe these values, right? But now the only thing is that the values are kind of more accurate. And they are in decimals. Magnesium is no longer 24, it's actually 24.3. In O levels, iron was 56. Bromine in O levels was 80, now it's 79.9. Okay, so make it a habit. Don't use your memories. Even if you think you know the atomic mass, just open the periodic table just to confirm, is that exactly the atomic mass that's given in the periodic table or not? Is this point clear?
Yes, sir.
Okay. So just don't depend on your memory. Every time, if you write 24 instead of 24.3, you'll end up losing marks on that. So first thing, don't rely on, when you're talking about AR and MR, don't use your memory. Open the periodic table actually. Okay. Now the thing was that when you looked at calcium, there's a small value and there's this big value, which is 40.1. First thing, what is the name given to this value?
Atomic number?
Okay, so it's the proton number or it's the atomic number. Basically, it's in simple words, it simply tells you the number of protons. That's it. So it's always going to be in whole numbers. Like if somebody tells you to give you the proton number, it's always going to be in whole numbers, because proton numbers, it can't be in decimals. Like you have 2 protons, you've got 3 protons, you've got 4 protons. It can't be in decimals. So it's always going to be written. It's always going to be a whole number. Never use decimals. Like we know it's 20, right? Like in this case, the protons are how many? 20. If you write 20.00, that would make, I mean, sometimes that would result in the loss of 1 mark, because what that suggests is that you think that protons can be in decimals. So to the examiner, that would indicate that you're not sure that, I mean, the proton number is always a whole number. Is this point clear?
Yes, sir.
Okay, so never write decimals with this. Okay, you have to be very clear. If they're asking for proton numbers and you have to write the number, you lose 1 mark if you write 20.0, because that tells them, okay, you think that it can be in decimals, but it can't be in decimals. Always a whole number. Okay, ye clear? Is this clear to everyone? Yes or no?
Yes.
Yes, sir.
Now the other point, what's 40.1? What do you call this?
Mass number.
Specifically, the correct word is the
number.
Nikon sir? That's known as the retroatomic mass. One thing about some people would be confused. One thing about this is, remember the position of these numbers can be anywhere. Different periodic tables have different, sometimes this number is written in front, sometimes on the left side, bottom, sometimes on the top side. Okay. So just remember, okay, ignore the position. Okay. The position is not what's going to tell you which one is the proton number and which one is the atomic mass. Just remember the smaller number is the atomic number and the bigger number is the relative atomic mass, which, I mean, they will always give you a key as well. Okay, that's the relative atomic mass. So don't look at the position, just look at the smaller number is the proton number, the bigger number is the relative atomic mass. As sometimes another word is used to describe this number. What is that other word?
Nucleon number.
So in this particular case, remember this one is not nucleon number. Okay, it's very close to being the nucleon number, but it's not exactly the nucleon number. Okay, so which is why even if you look at the periodic table, what you'll see is okay, they didn't write nucleon number. This is the relative atomic mass. It's not the nucleon number. They're kind of similar, but there's a very slight difference. TK, I'm going to talk about that difference, TK, right now. So just remember right now, if you use the word nucleon number, that would also result in you losing a mark. Okay. So it's not going to be a nucleon number. But coming back to the point, what are these two numbers? Relative atomic mass. As the first thing, when you're measuring mass of an atom, is mass going to be a whole number or is it going to be in decimals? Like you're measuring mass. Can
be both.
Is there a point? But it can be both, TK, but can it be in decimals, right? Like if I'm measuring my mass,
it can be.
TK, so it can be in decimals, right? It's always in decimals. Like it can always, like it depends on the accuracy of the machine. TK, for example, if I weigh myself, TK, if there's a device that's not that accurate, it might give the weight as 92 kg. TK, if I weigh it on a device that's even more accurate, that might give me up to 1 decimal place, 92.1 kg. So if some device that's very accurate, it might give the weight in 5 decimal places. So the point is, this value, it can be in decimals. Mass is always mass values can be in decimals. And depends on the accuracy of the device. How many significant figures? So mass, it can be in decimals. So what about the nucleon number? What is, by definition, what is the nucleon number?
Number of protons and neutrons.
So that's the number of protons plus neutrons. Ab iska batao, okay, if you're counting the number of protons and neutrons, can that be in decimals?
No.
Okay, so that's always a whole number. Okay, because you're just counting things. So it's a very subtle difference. Like, so you have to be very careful. Is the question talking, like they might ask you about, was it calculate the relative atomic mass of this thing, okay, or state the nucleon number of this. The nucleon number is going to be a whole number. It's going to be a very fixed whole number. But the relative atomic mass can be, it's always going to be in decimals, depending on the accuracy of the device. Now the thing is, okay, why do these two numbers are these two numbers almost the same? The reason they're almost the same is a proton and a neutron, what's the relative mass of it? That's given as 1, right? So if you have 40 nucleons, the relative mass would be 40, but it's probably going to be in decimals because the mass is not exactly, I mean, this is what we learn, right? I mean, this is what we learned, that the relative mass of proton or neutron, that's 1. But since we're talking about one, in O-levels you studied, okay, you read, okay, it's 1 but without any decimals. But the thing is, in reality, it's not going to be exactly 1 because it's mass. Mass depends on the accuracy of the device. It could be 1.0012. Okay, so it's not exactly 1. Maybe यहाँ पे ना मिल भी जाए relative. ये तो O-levels का just for example, this one. I think this is Britannica खोल गया. अच्छा, for example, this one, it's like the rest mass उसने proton की दी हुई है, ठीक है? The relative mass is not going to be exactly, I mean, it depends on the accuracy. The decimals can go on forever, okay, depending if you have a very accurate device. तो मैं वो देख रहा हूँ कि अगर मुझे वो मिल जाए relative mass of a proton in decimals, just a second. As anyways, I can't find it, but hopefully ये clear है कि जो O-levels में आप पढ़ते थे, relative mass of a proton, that's 1, that's not exactly 1. Is this point clear?
Yes.
Yes, sir.
ठीक है. So the point is, okay, when you convert the nucleon number, like if you have a nucleon number of 40, ठीक है, so automatically when you try to measure the mass and you add them all up, तो वो जो decimals में छोटी मोटी values होंगे, they might get added up to become 40.1. Or 40.1 followed by, depending on the accuracy, 40.123, something like that. Okay. So is this point clear? Okay, what's the difference between nucleon number
Yes,
and
sir.
तो इसका ख्याल रखना है, ठीक है? अगर retroatomic mass की बात हो रही है, decimals. Nucleon number, that's going to be a whole number. And there's another reason why it's in decimals. ठीक है? That's one reason mass can be in decimals and depends on the accuracy of the device. The other reason is, when you talk about relative atomic mass, the definition of this is, and let's write down the definition. Okay, it's the average mass of an atom compared to bio class start हो गया 11:50 है मेरे ख्याल से.
Yes, sir.
Yes.
As a compared to carbon 12. As so the second reason why it would be in decimals is, why is it the average mass? Calcium के सारे atoms की mass एक जैसी क्यों नहीं होती? Well, why do all the calcium atoms don't have exactly the same mass? Why do you need to take the average? What's the reason?
So their isotopes have different neutron numbers.
Okay, so the reason, so the thing is, the neutrons can go up and like you can have more neutrons. So that's why averaging has to be done. Every atom has isotopes. And whenever you do averages, you automatically go into decimals, right? So every atom has isotopes. Hence, their masses vary. So their mass varies. So averaging results in decimals as well. तो ये दो reasons है कि एक तो mass कभी it can never be a whole number. It's always because of the device accuracy. It would always be in decimals. The other reason is that you're averaging it. Not all calcium atoms will have exactly 40 nucleons. The neutrons and protons will go up and down. So So this mass represents the average mass of the calcium atom. ठीक है? वो exactly उसी तरह है जब वो apples लेते हो ना, not all apples are going to have exactly the same mass. They'll have similar masses, but the masses might go up and down. So that's why. So that is what relative atomic mass is. अब इन दो चीजों का ख्याल रखना है, ठीक है? कि moles के अंदर you're using relative atomic mass, not the nuclear number. ठीक है? The nuclear number is always going to be a whole number. So you have to be very careful जब ये formula करो ना, mass divided by ARMR. तो make sure you do this. Make sure you know कि कौन सी चीज लिख रहे हो आप. You lose marks. अगर उससे nuclear number is asked, write it in whole numbers. If the relative atomic mass is asked, that would be in decimals. ठीक है? Don't confuse the two. You clear? Any question on this? Is this clear?
Yes, sir.
Yes, it's clear.
चलिए ठीक है. Let's continue tomorrow then. ठीक है? Okay, everyone.
Allah Hafiz.
Take care. Allah Hafiz.